Hello cyber fans, let's keep doing this series from TryHackMe on Nmap. We did the Nmap live host discovery, and now we're going to do the Nmap Basic Port Scans. This room explains how to do TCP connect port scan, TCP sync port scan, and UDP port scan. You don't need anything to complete. Task 2 talks about TCP and UDP ports. So in the same sense that an IP address specifies a host on a network, among many others, a TCP port or UDP port is used to identify a network service running on a host. Like if you see service running on port 80, TCP port 80 is going to be like HTTP server, and if you see like port 443, it's probably going to be an HTTPS server. The more important things about the ports, like when you are scanning with Nmap, is to know if they're open or closed. Like open indicates that there is a service listening on that port. If closed indicates that there are no service listening on that port. However, there are more than open and close. You can have open, close, filter. That just means that Nmap cannot access the port, probably because of the firewall. You can have unfilter. That means that Nmap cannot determine if the port is open or closed, although the port is accessible. Say like this state is encountered when using acknowledge scan. Let's say, and you can have open filter, that Nmap cannot determine if it's open or filter, and closed filter, which means that Nmap cannot determine if the port is closed or filter. Which service uses UDP port 53 by default? That's going to be DNS. Yay! Which service uses port TCP 22 by default? That's going to be SSH. How many port states does Nmap consider? Here consider 6 states. Which port state is the most interesting to discover as a pen tester? It should be open. It doesn't make you any good to discover the closed port. You always want to discover an open port. This means that you can plan some kind of attack to that target. And yeah, that was that. Last, number 3 is going to be TCP flags. To understand the difference on TCP scans, TCP port scans, we need to understand like how the TCP header is built. And the TCP header is going to be the first 24 bytes of the TCP segment. You're going to have source port, like that's going to be the port in your computer when the packet is leaving. It's going to have a destination port, and that's going to be the port on the target computer that is going to receive the packet. It's going to have a sequence number, like a big file or something. It's going to be a sequence of packets, like each packet is going to have the sequence number. And like acknowledgement packet, that's going to be very important also, and that's going to be like the number of the next sequence. Then you're going to have a data offset. That's going to specify the size of the header, because you can have like, I think the minimum is 5 segments, because the options, perhaps you don't have any options there. And then you're going to have only 5, 1, 2, 3, 4, 5, and then the data. So you can have 6 with the options, or like more options. Then you're going to have a reserve. This section here is not being used, it's reserved for future use. Then you're going to have the control flag, so it's going to be urgent, and that packet is going to have priority over other packets. You're going to have the acknowledge. The acknowledgement that's going to be used in the three-way handshake. You're going to have the push. That's going to ask the receiver to push that packet into the application as soon as possible. It's similar to the urgent. You're going to have the reset. That is going to reset the connection. It's mostly to abort. You're going to have the sync. That's going to be used during the initial handshake. And the finish, that is going to be on in the last packet of the sequence. Then you're going to have a checksum, or the window size is like how many bytes, how much information can the receiver be willing to accept at that moment. And you're going to have the checksum. That is going to be used to verify that the data is correct. That's just to have to match. You're going to have the urgent pointer. That's going to be used in conjunction with the urgent flag. And then you're going to have more options that will help the communication and some padding to complete the length of like 4 bytes. In the case like those options are going to provide like 1 byte, 2 bytes. They're going to have some padding that is just going to be zeros. And then you're going to have the data in that packet. So here are the flags. You see urgent. The urgent flag indicates that the urgent pointer field is significant. Yeah, that's what tells you that it's an urgent packet, and then it's going to use the urgent pointer. And the urgent pointer indicates that incoming data is urgent, and the TCP segment with the urgent flag is set and processed immediately without consideration of having to wait on previously sent TCP segments. The acknowledge and the sync, we see it on the three-way handshake. You have just a sync packet, and the host, like the target send packet, and the acknowledge packet. Sync acknowledge packet. As we said, as we said before, is to finish the connection. Like it's more like to abort the connection when something is wrong, and the finish is like to finish the connection, like when you transmit all the data. And the question: what 3 letters represent the reset flag? Oh, the reset flag. RST. Yeah. Which flag needs to be sent when you initiate a TCP connection? First packet of a TCP three-way handshake. That's going to be the scene. Well, this is task 4, the TCP connect scan. The TCP connect works by completing a TCP three-way handshake. It's going to be like a normal handshake. The client is going to send a TCP sync flag. The server is going to respond with the sync acknowledge, and the client is going to send an acknowledge flag, and that's going to complete the TCP three-way handshake, and that's going to tell you that there is an open port on that server. But we're interested in just learning that the port is open. We're not interested in establishing a connection. Like when we finish the TCP three-way handshake, we send a reset acknowledge. That way we drop that connection. And if you see here in Wireshark, it's sending SYN package to every port, and Sometimes the server responds with sync acknowledge, and then we have the reset acknowledge. Here we can see like a whole handshake, like the client is going to send to port 143 a SYN flag, or like a package with a SYN flag. Then the server is going to respond with a SYN acknowledge flag. Then the client is going to send an acknowledge flag, and it's going to establish a connection with that three-way handshake. But right after that, the client is going to send a reset acknowledge. That way it's going to drop that connection, because we're just interested in find out if that port is open or not. And the switch on Nmap to do that TCP connect scan is going to be the ST. You're going to see it running here. ST destination machine is going to tell you what ports are open and what service are running. Inside we can use the -F to enable fast mode, and that's going to decrease the number of scanned ports from 1000 to 100. It's going to scan the 100 most common ports. And the R option can also be added to scan port in consecutive order instead of random order. This option is helpful when testing whether ports open in a consistent manner, for instance, when target boots up. We're here to the question. It says launch a VM, open the attack box, and execute Nmap SD IP address via terminal. A new service has been installed on this VM since our last scan. Which port number was closed in the scan above, but is not open on the target VM? Here we see the ports we have there. We're going to run Nmap on that IP. And we're going to compare what new ports are open. Okay, comparison is there. We have port 22 SSH, port 25 SMTP, 80, port 110. There are more, but is that one? 110. Yeah, it was that one. What service? Let's say it was top 3. That's mail protocol. Yep. Yeah, we're in task 5, the TCP SYN scan. This is a very good scan because sometimes it's more stealthy than the TCP connect scan, because it's not going to complete the connection. But with this kind of scan, it's going to you need root privilege to be a sudoer. But this is what's considered like a half open scan, because it's not complete the connection. When you do the Nmap SS target, it's going to send the package with the SYN flag to the server. It's going to receive that SYN acknowledge packet, and then it's going to send a reset packet. It's not going to complete that three-way handshake. And sometimes some SIMs perhaps don't grab that, because some applications don't log that kind of connection because it wasn't complete. But really, any SIM nowadays is going to detect that. With this one, also Wireshark is going to grab the packet, and the packet is going to look a little bit different, like a normal packet. I think they can detect it faster because of that. You can see here in Wireshark, sending SYN package. and sending the reset acknowledge. Here it should be a complete picture. He's sending a sync package to port 80. The server is responding with a sync and acknowledge. Oh, this is the ST. Yeah, that's normal. Then the client is responding with an acknowledge, and then it's sending the reset acknowledge. Yeah, this is completing a three-way handshake. That's going to be the ST, and the one we are seeing right now is going to be the SS. That's going to be the half open. When it's going to send the SYN package to port 80, server is going to respond with the SYN acknowledge, and then right away we send a reset and end that connection. The TCP SYN scan is a default scan mode when running Nmap as a privileged user. Yeah, you need to use sudo to be able to run that scan, and it's going to be the default. Let's go to the question, launch the VM, and execute the Nmap with the SS on the target. And here we're going to compare. It's going to launch Nmap using the sudo, and it's going to give you a list of ports. It's looking for port 6667. Yeah, it was that one. What's the service name? IRC. Yeah, and that's it. Well, we're in task 6. It's going to be UDP scan. And UDP is connectionless protocol that makes it harder because sometimes like UDP, I mean, if you have a connection, UDP is not going to respond to you. It's not going to give you like three-way handshake. It's not going to give you feedback. And we cannot guarantee that the service listening on UDP port will respond to our packets. The best way is to send like an ICMP is to receive an ICMP port unreachable error. That's going to be a type 3. If the port is closed, like usually if the port is open, you do the SU, that is an Nmap SU, and the target is going to send a package, an UDP package, and the server is not going to respond if it's open. But if it's closed, it's going to send you an ICMP type 3 code saying that the port is closed, like I mean saying destination unreachable. Here with Wireshark we can see the client sending UDP package to the server and the server responding destination unreachable. Here we can see it launching a UDP scan against a Linux server. Looks like port 111 is open. And Nmap cannot determine if the port 68 is open or filtered. Yeah, you can see it here. And it looks like we're going to do the same. We're going to launch an Nmap using the fast option. I did it already because like the UDP is very slow scan. Yeah, it takes a while to scan, even with the fast option. The new service has been installed. Okay, we have to compare against these. Yeah, but there are a lot of, well, most of them are filtered. We really don't know. Oh, looks like some 353. Yeah, it was filtered 53. What is the service name according to Nmap? That's going to be DNS. Domain, yeah. Good. We are on task 7, and that's going to be fine-tuning scope and performance. So you can specify the ports you want to scan. By default, it's going to scan just the first 1000 port. But sometimes you don't need that. You need a specific port. You say like P22, 80, and 43, and it's going to scan only these 3 ports. You're looking for a specific server or SSH, or you can give it a port range like from P1 to P1023, and it's going to scan all the ports in that range. It's going to be inclusive. It's going to scan the screens. And it's going to hear another example from P20 to P25. And you can just put like -P and a dash, and it's going to scan all the 65,535 ports. And using F, it's going to do the fast scan for 10 ports. And you can do it for 100 ports, I'm sorry. And you can do top ports for scan the 10 most common ports. Also, when scanning, you can control the speed. You can use the T, -T, a number from 0 to 5, and it's going to be from super slow. It's going to wait 5 minutes to probe each port, to super fast. And you really don't want to use that 5 because it's going to drop package and it's not going to be that reliable. Normal scan speed is going to be T3. If you don't put anything, it's going to be a T3. And you can use like T4 if you want to be more aggressive. You're just in your lab. But mostly when a real engagement, people tend to do T1 to be very slow and don't get discovered. You also can control the rate, like how many packets per second is sending. You can use min rate and a number, and max rate and a number, and that way you control the amount of packets. But you can control the parallelism also to send the amount of probes that are scanning in parallel. And you can use the min parallelism and max parallelism and a number. And you see here is equal 512. That pushes Nmap to maintain at least 512 probes in parallel. And what is the option to scan all the TCP ports between 5000 and 1500? And I think it's going to be -P 5000 dash submit. Yeah, was that? How can you ensure that Nmap will run at least 64 probes in parallel? Okay, that was going to be the parallelism. Can copy these. And it's going to be 64, it was? Yeah, 64. Yeah. What option would you add to make Nmap very slow and paranoid? That's going to be the T0. And yeah, that's it. Yeah, and this is task A is going to be a summary that everything we learned in this TryHackMe room about port scanning. There are 3 main kind of port scans. They're going to be a TCP connect scan that is going to make a 3-way handshake. There's going to be your TCP SYN scan that is going to start the 3-way handshake, but it's going to drop it. It's not going to finish the connection. And it's going to be the UDP scan. You have the ST, the SS, and the SU. And here there are different switches or types scan you can do, like options you can add to your scans, like P to control the ports. You want all the ports or use a fraction of the ports. F is going to be fast scan, it's going to be the 100 most common ports. R is going to scan the ports consecutively. With T, you're going to control the speed. That is very used, like P and T are going to be very used. And then you can control the rate also, or the parallelism. And yeah, that's it. You can complete it now.